Do you see that? Okay, now let's just say you were solving an equation like x equals 4, or I'm sorry, let's say it was like 8 equals 4x. Okay, the 4 is multiplying the x, so you would divide it. Because it's multiplying, you divide. The t squared is multiplying the g. So how do you undo multiplication? Division. You divide by t squared. And again, you just cross them out. There's no like math action that you're taking. And so you've done it. G is solved for. G is L 4 pi squared over t squared. Any questions on that?
No.
Okay, let's look at the next one here. On these projects, do they give you an attempt that is exactly the same as the previous one, or do you get new questions each time?
For a project, I don't really know.
Okay, well, what I'm looking at, you'll definitely want to retake this, and maybe with a bit more help here, you can get a perfect score. Again, it just appears difficult, and everything is impossible the first time you do it. So you get over that hump, and then you're like, all right, what do I got to do here? Which variable are we solving for in this?
Q.
And it's like really important that you remember that, because that's one of the most common things that students, they forget, like which variable are they subtracting or getting, which variable are they solving for? So my preference is always to get rid of stuff on the bottom. How do you undo division?
Multiplication.
And what should you multiply both sides by to get rid of this r squared on the bottom?
R squared.
R squared. And again, the nice thing is like there is nothing to do. You just write ER squared. These cancel, K times Q. So again, which variable are we solving for?
Q.
Q. And it's good to either highlight it, mark it, somehow indicate like, yeah, that's the one we're solving for. How do you undo multiplication by division? These cancel and you're done. Q is E r squared over K. Now it is also possible that the order could be flipped around, like it could be r squared E over K. That's also correct. You have to be flexible with how the answer appears.
Okay.
Okay, so we've done a couple of questions where the variable we're solving for is in the numerator, and that's the best case. That is absolutely the best case. So of course they're going to give you some problems where it's not in the numerator. Definitely not. So see how A is in the bottom, and that's bad. That's really bad because it's just bad. Now, how can we write G as a fraction? What can we put on the bottom?
1.
Okay. So there's a couple options from this point forward. You can either flip both fractions. I don't know if you've seen that before. Have you seen that before?
No.
Okay. I like that approach, but a lot of students don't. We'll just put that off to the side for the moment, maybe come back to it. What most students do is they multiply diagonally. They do this sort of butterfly thing. Have you seen that before?
Yes, I have.
Okay, so we'll go with that for the moment, although I think the other one's actually better. So it's G times A times X equals 1 times F times L. And again, super important that you're like, all right, I'm solving for A. I'm not solving for, G, and you get yourself confused on that. Is the one needed anymore?
No.
No, you don't write it unless you need it. In this case, it's implied that it's there. So we can write G times A times X. If you need to, if you need to, because it's more comfortable, you can rearrange it so that the G and the X are next to each other.
Okay.
Doesn't really matter, but like you want to get rid of both of them. So you get rid of both of them by dividing them out.
Oh, okay.
And like, yeah, you can divide them both at the same time. Why not? I mean, you have, if you, but if it's the first time you've seen it, you're like, well, I don't, I'm not sure. Is that okay? Yeah, it's okay. It's totally okay. Did you get this down in your notes?
Yeah.
Because I'm going to have you do a similar problem to this, and I want you to be able to do it on your
Okay,
own.
give me a sec.
Yes.
Okay, got it.
Awesome. Okay, so I'm just going to make one up here. This is the equation. So Jeremiah, you got M times E over pi times X. I want you to solve for X. Okay, so take a minute or two, whatever you need, but give that a try. It's no different than the previous problem, just different letters, but it's the same set of steps.
I think I have it.
Okay, how confident are you in your answer?
Pretty confident.
Okay, so if I said you got to do 10 push-ups, if you get it wrong, you're like, no, I'm not gonna have to do any, or you don't mind doing push-ups.
I hate push-ups.
You hate push-ups. Okay. All right, go ahead and give me your final answer.
X equals EM on top and bottom pi J.
Okay.
Yep.
All right, so let's just talk about how to do this. Now, I said this in the previous problem, you could actually flip both fractions. So I'll just show you that other approach here. And if you multiply both sides by M times E, okay, so we're looking pretty good here. You're gonna, those cancel, and M times E times 1 is ME over J equals pi times X. Now you divide by pi, and this is where maybe a student wouldn't know where to put the pi, but it actually goes on the bottom. Your answer is 100% correct. 100%. Perfect. No push-ups. Why don't you like push-ups? What's wrong with push-ups?
I'm not good at them.
Okay. How about pull-ups? Pull-ups, any better?
Nope.
No. Okay. Okay. All right. We'll stop talking about strength training. We'll get back to the math. All right. Solve for W. So sometimes they choose letters that kind of look like the other letters to be confusing. And that's again why I'm like, I would tell you it's a little bit extra work, but either highlight or somehow indicate like, yeah, that's the letter that I'm solving for. Okay. So on the left here, it's really, and this is a Greek letter called rho, which doesn't really matter, but it's not P if you want to be completely formal. But again, you could just cross multiply here. So you get that rho times L times W times H equals M. And what's really nice here is you don't have to reorder it the way that we were doing, but you can now just you can just divide by the other letters. So you get your W equals M over rho times L times H rho. row. Any questions on that so far?
No.
Okay. So why there's so a lot of times students ask, they say, hey, Matthew, why do I need to learn this? And I don't really have a good explanation for why you need to learn like this literal equations. Here's when it's used. It's used on the SAT and ACT. So are you planning to go to college?
Not really.
Okay. Well, if you do and you take one of these standardized tests, you're going to be asked to solve some problems like this. If you take chemistry or physics, which you may have to do, they tend to use these literal equations. And there's some reasons for that, but it's really preparing you for something else that you're going to take in the future. All right, so let's take a look here. New question here, solve for C. So C is in the numerator. That's way better. Now these cubes and these squares, they don't matter. You just divide by m squared, or multiply by m squared, like whatever you have to do. You don't have to. They're just kind of like additional things that are irrelevant. Do you want to give this one a try? Do you have confidence that you can solve this?
No, not really.
Okay, I believe in you. Okay. How do you undo the division?
Multiplication.
What do you multiply both sides by?
AJ.
AJ, because it's the same, so it clears it out. And on the left side, the order does not matter, but I'm going to put A and J after it. If you always identify what letter you're solving for, it helps to give you clarity on what is left to do. The K and the M squared, the kilometers squared there, it's actually just K times M squared. They're multiplying it, so you divide it out. And they cancel. So your final answer is S cubed, A times J, K times M squared. Okay, let's look at one more here. Okay, so I want you to try solving this for letter M. Can you do that for me?
Okay, I think I have it.
Okay, what is your final answer?
3 cube 2GMT.
Wait, hang on a second. You said 3 cubed. Did you mean A cubed?
Yes.
Okay, A cubed. Go ahead.
A cube 2GMT square pi.
Okay, hang on, because you're giving me the exponent first. Do you mean the pi squared?
Oh, yeah. Read that wrong.
That's okay. And in the future, you can send a picture or something, but okay, here, let's do it differently. I'm gonna work it out. I'm gonna work it out here. And you tell me if your answer is the same as this, meaning that the order is the same. So M is gonna equal 4 pi squared a cubed over t squared g. Does that look like your answer? And the order could be different, like the a cubed could come first, the g could come before the t squared. Does that look like your answer?
No.
Okay. All right. Let's move to a new topic. We'll get some coverage on something else here. And you did really well on all the problems. So I'm gonna just assume that was just a whatever. Factoring perfect square trinomials. So we're going to something completely different. Completely different. You probably have seen this before. So this is what it is. X squared plus 6x plus 9 factors into the following: x plus 3 squared. Can you in any way tell me how I got the 3 from this equation on the left? Any idea where that came from?
You subtract them.
Okay, good guess. Watch the following. So this becomes x plus 4 squared. So your subtraction doesn't work this time. What's another option maybe?
Multiplication.
Okay, closer. Now you're used to the following operators. You're used to addition, subtraction, multiplication, divide, but there's also exponents. And then how do you undo exponents? Like how do you undo a square? Square root. Okay, so let me show you this. Let me back up here. X squared plus 6x plus 9. What is the square root of 9?
Square of 9.
Yes. Have you seen this before? Square root symbol?
Yeah, I've seen that before.
So what I'm asking for is what number times itself?
It's 9.
Yes.
3.
3. The square root of x squared is x. That's just something you're going to have to know. Okay. Now, if you multiply x times 3 together, what is x times 3? 3x. And if you double it, is that now 6x?
Yes.
It is. Okay. So these are the requirements for a perfect square trinomial. We're gonna do a bunch more here, but that's just the start of it. All right. Just double it and you get 6x. Yeah. Okay, let's look at another problem. Let's say it's x squared plus 10x plus 25. So let's start by taking the square root of 25. What number times itself is 25?
5.
5. The square root of x squared is always x. If you multiply these together, you get 5x. And if you double it, do you get 10x?
Yep.
Yep. So here's what this becomes. It becomes x plus 5 squared. Do you see where the x comes from and where the 5 comes from?
Yep.
Okay. So if you understood that, what does this become? What is x squared plus 16x plus 64? What is the first thing that we take the square root of?
64.
Yep. What's the square root of 64?
I don't know. That's too big of a number.
Now you can do this. You can do this. So like 10 times 10 is 100. That's too big. Okay. 4 times 4 is 16. That's too small. Find something in the middle. Like what's 6 times 6?
Ooh, that's 12.
Multiplying, not adding.
36.
36. So it's bigger than that. 7 times 7.
49.
49. And then 8 times 8 is your winner, 64. Okay. Let me go grab, so on my website and on, a million other places out there on the web, of course, there is a squares and square roots reference sheet. And you definitely need this. You need to know this to be able to do well in this part of the course, or you got to have that calculator out so you can do it really fast here. But you need to know basically all the squares and square roots up to 10 or 15, something like that. So this is 8. So 8 goes on the right here.
Okay.
And the square root of x squared is x. So that goes in this first position. Okay, let's try one more here. Let's try x squared plus 2x plus 1.
1.
Yeah, the square root of 1 is 1. So what else goes in this parentheses? What's the square root of x squared?
X squared.
X. So in all the problems we did, see how the square root of x squared undoes
Oh
the
yeah,
square?
yeah. Okay.
And then we always put an x in there. Now it will get more difficult than this, but that's kind of your starting point here. Let's try one more. Come on, you can do this. Let's go x squared plus 18x plus 81. What is the square root of 81?
Um, 81. 8.
We already did 8 squared. 8 squared is 64.
All right.
If you click on that link I sent in the chat, that'll take you to a reference sheet that has the answer on it.
Okay.
It does me no good to just give you the answer because I already know it. You got to be able to, search the web, grab a calculator, something to be able to find this number.
It's 9.
9. Perfect. So that goes on the right side here. What is the square root of x squared?
X.
X plus 9. Perfect. All right. Well, that does take us to the end of our lesson for today, Jeremiah. I hope you get to do something fun over fall break. If you have some time, try to work on some math in some way, even if it's something short. Practice really will only help you at this point. So that is it. And I'll see you next time.
Okay.
Have a great night. Bye now.
Yeah.